Hello viewers, welcome to Autonomous College. Today we are going to discuss about a new concept and a new topic that is known as Deterministic Finite Automata, and it's the topic of part 2. In a previous topic we already discussed about what are the real concept of finite automata and what are the different types of finite automata we have. Then we are learning some data about our deterministic finite automata and how to create a definition of that deterministic finite automata with 5 tuples and different parts of that deterministic finite automata. Here we are going to discuss some few topics outlines. Now we can focus on a slide. In this slide discuss about some different concept like what are the different terms of transition tables. Then we are learning what are the different examples which are related to our transition table, and what are the different examples can be used in our DFA and to create a specific table or a specific transition diagram according to their different types of expressions. Now we are learning what is the real meaning of that transition table. Here in this slide we already have the transition table is basically a tabular representation of the transition function, which takes two arguments, a state and a symbol, and returns a state. That means whenever user want to create a new state, in that moment user must put two symbol, that may be a, b or 1 or 2 or whatever, 0 or 1. According to that symbol we can create a new state, so that in that state we have number of functions. Like if a user want to create some states, combination of more than one state, that is denoted in capital Q, which is known as the set of more than one states. Whenever user want to create a initial state, in that moment we can be denoted as Q0. That Q0 is known as the initial state of a specific transition diagram. Next we are having what are the different type of transitions we can create. It is already denoted through delta. Now we can focus on a slide. In this slide already we have discussed how to create a transition table, so that the transition table is always focused on few points. Here already we discussed here, like in the first point already we have the columns correspond to the input symbol. In that symbol we are specially mention a column. In that column we are taking some input symbols, that may be alphabet, that may be any digit. Generally we take always input symbol as a 0 or 1, or we can take the alphabet A, B, as well as if a user want to take more than one alphabet, it is also possible, but still it is not used in our transition diagram, but we are only taking two transition symbol here. Then we are taking the rows which is correspond to states. That means if a user want to create a new states, in that moment we are create some rows. In that rows we are mentioning some states. If a user want to put a specific input symbol, according to that input symbol we are generating a new state, then that state must be mentioned in our rows, and in that rows we are mentioning different values of that input symbol. The third point is denoted as, which is entries correspond to the next state. Whenever user can put a symbol, in that moment we are creating a new state, and that state is known as a next state of a transition diagram. Next we have a concept that is known as when the user want to start a state which is denoted by an arrow with no source. That means if a user want to create a new state, in that moment there is no need to put a input symbol. In that time it is known as a starting state. That means if a user want to create as the initial state, that may be suppose you can think that if a user want to put 0, that 0 may takes to a specific state, and that state known as initial state. According to that transition it may be self-transited or it may be created a new state. That is a way of explanation through which is mentioned in our transition diagram. Last but not least, here the accept state is denoted by star. That means if a state is really accepted, or we can say it is known as a final state, in that moment in our transition table which is denoted as a star. Whenever user can put a star, a specific state, that means that state is known as a final state. We know that in the graphical representation each and every final state is always denoted through two round circle. According to that two round circle we can create that transition state as a accepted state. Next we are going to discuss about how to create that transition table through a transition diagram, because we know that if a user want to create a transition table as well as we can say transition diagram according to different functionalities. If a user can create a transition table, that is only possible through a transition diagram. If a user want to draw a transition diagram, it may create a one statement which is given by a specific example according to their functionality. Otherwise you can take the help of some regular expressions. According to that regular expressions, we can also create a transition table or transition diagram. But one thing is most important: if a user want to create a transition table, a user must to draw a specific transition diagram. Without that transition diagram, we never to create that transition table. Sometimes we have a transition table as an example, as a question. According to that example of transition table, we can create a transition diagram. It is also possible. But here in this example, we only have a transition diagram. From that transition diagram, we are going to create a transition table. Now we can discuss about it. Here we have a transition diagram like if a user take an initial state as a q0 and that q0 can take a input symbol 0, then it can create a new state that is known as a q1. Whenever user can put another input symbol 1, then it can move forward to q2. But here that q2 is denoted as a final state. From in that q1 state, if I consider, then whenever a q1 can accept a input symbol 0, then it is self redirected to another state that is known as a q0, which is known as initial state in this example. Then if a user want to put that is known as 1 as an input symbol, then it can create another new state, but that state it is located in your q2, which is known as accepted state, or we can say final state. But each and every state must be take some input symbol. That's why that final state also takes two input symbol as 0 or 1. Whenever it can take two input symbol like 0 or 1, then it is known as self redirected to q2. Now we are going to discuss about the transition table here, which is the solution part. First of all, we can create a 3 column. In that 3 column, the first column named as a present state, the second column known as a next state for input as a input symbol given here 0 or 1 we are taking. That's why the first state input symbol is considered as 0. The next state for input 0. Then we are consider another third column known as next state of input 1. Whenever user can start its input processing, in that moment user can take as a 0 to a new state that is known as a current state that is known as q0. In that moment, whenever q0 can take input symbol 0, then it can create a state that is known as q1, which is written here. If user can take 0 to the initial state q0, then it can create a new state that is known as q1. Similarly, if a q0 can take another input symbol 1, then it can create q2, which is mentioned here. Next, we have another state known as q1. In the case of q1 state analysis, we can take the 0, then it can create a which is directed to q0, which is located in this table location. And in this field already we mentioned here q0 as a which is created from the taking input symbol as 0. Whenever user can take 1 to the q1 state, it can create a q2, which is already mentioned here. Similarly, that q is known as accepted state, that's why it is denoted as a star. Star means it is known as a final state as well as you can say accepted state. In that accept state, we can also take 0 or 1 as an input. Whenever user can provide 0, it is self redirected. That means that q2 can take 0, then it is self redirected to q2, which is already mentioned in this table field. Next, it can take the 1, which is self redirected to q2. That's why if a user want to taking more than one symbols, then if that symbols must be self redirected, then we can written like that. That means 0, 1. Whenever user can write here 0, 1, that means that q2 can self redirected after taking this two input symbol 0 or 1, which is already explained in this explanation part. We can learn about it. In the above table, the first column indicates all the current state. Under column 0 and 1, the next states are shown here. In this table already discussed, the first row of the transition table can read as when the current state is q0 and on input 0, then the next state will be q1, which is already mentioned here. On the input 1, the next state will be q2, which is already discussed in that table. And the second row When diagram already we can discuss here some explanation part. In that part we are already discussed in the second row, when the current state is Q1 on input 0, then the next state will be Q0, already mentioned in this diagram. On input symbol 1, the next state will be Q2, which is already discussed in this transition table. In the third row, when the current state is Q2 on input symbol 0, then the next state will be Q2, which is already mentioned here because it is self redirected in this transition diagram. On input symbol 1, the next state will be Q2, which is already mentioned in this transition table. So that the arrow marked to Q0 indicates that it is a starting state, or we can say initial state in this transition table, and the circle marked to Q2, which is indicated as a final state. That means we have a double rounded circle, means it is known as a final state, and that final state is always located in star mark, and that star mark means it is known as a final state in this diagram, or you can say in this transition table. The next example, which is also related to our transition table, and this is known as a transition diagram. From that transition diagram we can create a transition table, and now we can look at whenever a Q0 can take input symbol 0, then it can self redirected to Q0. When a user can provide some another input symbol like 1, then it can create a new state, or you can say next state, that is known as a Q1. Similarly, that Q1 state also take two input symbol 0 or 1. In that moment, if a user can provide 0, then it is self redirected. If a user can provide 0 or 1, at that moment, sometimes in this case we can create more than one states, it is also possible. In that moment, if a user can take another 0, then we can create another new state like Q2. Whenever user can also put another input symbol 1, it is also redirected to Q2. That means after taking this 0 input symbol, we are getting two input, or you can say two new state, that is known as a Q1 or Q2. Similarly, that Q2 can also take two input symbol 0 or 1. Whenever user can take the input symbol as 1, then it is denoted to Q, which is known as a Q3. In that Q3 is known as a new state, or we can say, and that state is denoted as final state, which is mentioned here. If a Q2 can take 0 as an input symbol, then it is redirected to Q1 state. That means it is a way of explanation which is already mentioned in this transition diagram. So that this transition diagram need to be created transition table, which is explained below. From that transition table already we have three columns. The first column known as the present state, next state for the input symbol 0, next state for the input symbol 1. But here in the present state we can explain four columns here, because we have creating four new states. That's why we have four rows, and the first rows we have a state that is known as a Q0, which is known as initial state, which is denoted as arrow mark, which is already explained in this explanation part. Similarly, whenever user can put 0 in the Q state, we are getting the same state. That's why it is mentioned here Q0. If a user can take another input symbol 1, in that moment user can create another state that is known as Q1. Similarly, in that Q1 state also we are taking some input symbol 0 or 1. Whenever user can put 0 to Q state, in that moment we are getting the two state. That means first state known as a self redirected. In the second 0 we are getting the new state, which is explained here. Whenever user can put 0, then it is mentioned as a Q1, which is already located here. Whenever user can put another 0, which is mentioned here, then we are getting Q2, which is already written here. That means in your Q1 state 0 is inputted, then we can get another two states known as a Q1 or Q2. Similarly, whenever user can put another input symbol 1, then we can create Q2, that is known as a new state, which is mentioned in this column. Similarly, we have another state known as a Q2. It can also take two input symbol 0 or 1. In that moment, after taking that 0, then you are getting Q1. After taking that 1, you are then getting Q3. Last but not least, here we have another last state that is known as a Q3, which is known as a final state, or you can say accept state. In that state, which is already mentioned here as a star, whenever we are getting any state which is denoted with a star mark, then we know that it is known as a final state or accept state. Whenever user can put 0 in that Q3 state, then you are getting that is like Q2. Q2 is known as a self, not redirected, it is a new state which is already created in the previous section, and that is known as a Q2. Then Q3 can take the input symbol 1, which is also directed to same state like Q2, which is a backward movement, that is known as a back propagation in that state movement, whenever it can take 0 or 1 at the time of final state. So in this way we are getting the transition table, so that sometimes if a user want to design a DFA diagrams according to the question, we can design that diagram as well as we can create a transition table. Sometimes the transition table is essential for a DFA diagram, otherwise we can only draw the transition diagram, then we have the explanation. But according to the need of that question, sometimes the user must follow these two parts. We can create the transition table as well as we can design the transition diagram with explanation, which is so impressive marking, so that we can follow these three parts. We can create transition diagram, transition table, then explanation of that transition table, which is already discussed in this part. So here already we have the first row of the transition table can be read as when the current state is Q0 on input 0, then the next state will be created, which is mentioned here Q0. On the input symbol 1, we can create another new state that is known as Q1. Simultaneously we can create more than one states according to this transition diagram. So that these are some transition tables related explanations which is mentioned here, but now we are going to discuss about how to create a DFA according to a specific question like your regular expression or some statement. So that now we are going to explain how to draw a transition according to their explanation here. Some like we can put some states which is given in this diagram like Q, then we have two input symbol which is written as a summation, then we have initial state which is given in our question like Q0, then we have a final state which is already mentioned here, that is known as Q2. So according to that value or parameter, we are going to create a transition diagram. Whenever user have three states Q0, Q1, then Q2, so that from that requirement we are going to design this transition diagram, so that whenever user can take like Q0 with some input symbol 0, then we can create a new state like Q1. Whenever user can put as a 1, then we are getting that 1. Whenever user can take the 0, then we are taking self redirected, or use is known as a Q0 state, already explained in our transition diagram. So that in that transition diagram we have some explanation like which is denoted as arrow mark, means it is known as initial state which is given in our question or example, and whenever user can provide that 0, it is self redirected and it creates a Q0 state, and whenever user can put 1, then it can create another new state that is known as Q1. Similarly, that Q1 state can also take two input symbol 0 or 1. Whenever user can put symbol 1, in that moment user can create a self redirection state that is known as a Q1 state. Whenever user can put 0, in that moment user can create a new state which is known as a final state that is known as Q2, and in that Q2 where it is known as final state, that's why that Q2 is always denoted as a asterisk or star mark. So that if a user want to design that transition table, which is optional in that case, so that user must put some input symbol according to its requirement. But here we have a final state. In that final state we can take 0 or 1 which is self redirected. That's why that self redirected state, it is known as the same Q2 state which is mentioned in this transition table. That's why that Q2 is known as a final state which is located in the form of asterisk, or you can say star mark. Then we have two state which is known as self redirected state, that is known as a Q2, which is already mentioned in this diagram. In this transition diagram already we have designing how to create a DFA according to some input symbols and different type of states which is given in that example. But in the next slide we are going to discuss about we can create same DFA according to some different type of questions variations. So that we are going to discuss in our next class. Okay, finally, thank you. Have a nice